السلام عليكم ورحمة الله وبركاته. هاي المحاضرة المسجلة الثانية chapter 3. راح نكمل فيها اللي تعلمناه. We are going to continue from where we stopped last time. In the previous lecture المحاضرة الأخيرة أو المحاضرة الماضية we stopped at single cash flow. عند single cash flow وشفنا ال compounding factor and compounding factors of single cash flow. تعرفنا على ال compounding process على discounting process. تعلمنا and we learned how to use the notation form to write the formula instead of using the complete formula, and we also learned how to use interest tables, and we solved two examples. One of them is a compounding process, given B calculate F, and the other one was a discounting process, calculate F given B, calculate B given F. Okay, and now we are going to solve example 3.9. We have four variables in the compound interest formula. We have future value, present value, interest rate I, and number of interest periods N, and we can solve the equation for any of these four variables. نقدر نحل المعادلة لأي واحد من هذول الأربع متغيرات provided that we are given the other variables. We can calculate F given PIN, calculate B given FIN, calculate I given FPN, calculate N given FBI. Example 3.9, suppose that you buy a share for $20 and sell it for $40 after 5 years. What would be the average annual interest rate or the rate of return on your investment? Or simply, given present value of $20, future value of $40, and N equal 5, calculate I. We can solve this problem using the compounding formula or the discounting formula. Calculate F given PIN or calculate B given FIN. We are going to use the compounding formula F equals P for 1 plus I to the power N, and rearranging this equation or solving this equation to I, we will get I equals F over B to the power 1 over N minus 1. Plug in the numbers and you will get the answer of 0.1487 or 14.87%. This is the interest rate. How we got this formula? We simply derived it from this formula as follows. Divide both sides by B, F over B equals 1 plus I to the power N. Take the nth root of both sides. F over B equals 1 plus I, or I equals nth root of F over B minus 1. The other example, you purchase 100 shares of General Electric stock at $6 per share. You will sell the stock when market price has doubled. The stock price to increase 20% per year. How long you have to wait? So given present value and future value and interest rate 20%, how long do I have to wait until the share price doubles? First of all, we need to find the present value. So I bought 60 shares. The price for the one share is $100. So my present value is 6,000. And I wanted to double, so I will multiply it by 2. I will get $12,000. So same thing, we are going to use the compounding formula F equals P for 1 plus I to the power N, and deriving or solving the equation for N as follows. Divide both sides by B. F over B equals 1 plus I to the power N. Now we take the natural logarithm of both sides. Ln F over B equals N multiplied ln 1 plus I. So N equals ln F over B divided by ln 1 plus I. Plug in the numbers, we will get 3.8 years, and we always round it to the highest number, 4 years, because the interest is due at the end of the interest period. So we always round up to the highest number. دائما بنقرب العدد الأعلى. Suppose that the answer was 3.2, then we will round it to 4 years. دائما بنقرب للرقم الأعلى لأنه الانترست تستحق عند نهاية الانترست period. And if you put your money in the bank and withdraw them before the end of the year, you will not get the interest for that year. إذا أنت حطيت فلوسك في البنك وسحبتيهم قبل لا تنتهي السنة ما راح يعطيك الفائدة على هذيك السنة لأنه لازم يمر عليهم سنة كاملة في البنك. Now we come to the fifth type of cash flows, which is the irregular cash flow. In irregular cash flow, we treat each transaction as a single payment cash flow and either find its present value or future value. But as a common practice, we always find the present value. So this transaction, we will find its present value after one interest period. This transaction, we will discount it for 2 interest periods. And this transaction, we will discount it to 3 interest periods. And the other one discounted for 3 periods. And the last one, we discounted for 5 interest periods. And there is nothing you can calculate either B or F. ما في إشي بيمنع. نقدر نحسب ال present value أو ال future value. لكن يعني as convention زي كما اعتاد عليه الناس إنه دائما إحنا بنحسب present value and we can always convert the present value to a future value using the compounding formula of a single payment cash flow. First example, how much do you need to deposit today to withdraw 25,000 at n equal 1, 3,000 at n equal 2, 5,000 at n equal 4. Okay, at interest rate of 10%. And I have those transactions. Okay, how much I have to deposit in the bank today to be able to do these transactions. We treat each cash flow as a single payment cash flow. For the 25,000, we are going to discount it for one interest period. For the 3,000, we are going to discount it for 2 interest periods. For the 5,000, we are going to discount it for interest periods. So B1 is calculate B multiplied, calculate B given F at interest rate 10% and 1. Using the interest tables, the factor is at 10% and one interest period is 0.90909. You will get this answer. B2, multiply the 3,000 by calculate B given F at 10% and 2 years, and from the interest tables at 10% and 2 years, the factor is 0.82645. Multiply it by 3,000, you will get $2,479.35. And for the 5,000, multiply it by the factor, calculate B given F at 10% and 4 interest periods. And from interest tables, the value of this factor is 0.68301. Multiply it by 5,000, you will get 3,400 something. Now the total present value is the summation of B1, B2, and B3, which is $28,621. The other example, irregular cash flow, but this time it is with varying interest rate. The interest rate changes from 1 year to another year. The same as before, we are going to treat each cash flow as a single payment cash flow. But since the interest period is varying from 1 year to another year, first of all, let's see what we are going to do for the first cash flow, the $300, and we can apply the same principle for the other transactions. راح نشوف ايش بدنا نعمل ل $300 راح نطبق هذا الكلام على ال 500 وال 400 transactions. So for the $300, we are going to compound it for 1 year at 5% interest rate. Now for the second 2 interest periods, the interest rate is the same, 6%. So this one, which is equivalent to 300 at n equals 0, we are going to compound it for 2 interest periods at 6%. You will get this value. Okay? And this transaction now we can compound it for 2 interest periods at 4% to get its future value at n equal 5. And we can apply the same principle for the 500 and 400 transactions. So for 300 at n equals 0, 300 multiplied by fp 5% and 1, this is the value of the 300, or the equivalent value of the 300 at n equal 1. If I multiply it by calculate f given b at 6% and 2 interest periods, it's going to be the equivalent value of the 300 at n equal 3. And if I multiply it by calculate f given b at 4% and 2 years, it's going to be the equivalent value of the 300 at n equal 5. The answer is $382. And we do the same thing with the 500. 500 multiplied by fp 6% and 1 year. Okay, this is 6% for 1 year. Then multiply, I will find its equivalent value at n equal 3. Multiplied by calculate f given b at 4% and 2 years, I will find its equivalent value at n equal 5. And for the last transaction, which is 400, there is only one interest period at 4%. So 400 multiplied by calculate f given b, 4% and 1 year. The total future value is the summation of f1, f2 and f3, which is equal to $1,372. الفيوتشر فاليو هي مجموع ال F1 وال F2 وال F3. The second type of cash flows, which is the uniform cash flow or equal payment cash flow, this is the standard form of the equal payment cash flow. Note that all the transactions have the same amount, and most importantly, there is no transaction at n equals 0. The equations we are going to develop now applies for this part of the cash flow. It doesn't include any transaction at n equals 0. If there is any transaction at n equals 0, we have to treat it separately as a single payment cash flow. The factors used for uniform series, we have 4 factors. The first one is calculate f given a, which is the future worth factor. If I have annuity, I want to convert it to a future value after n years. The equation is a multiplied by 1 plus I to the power n minus 1 over I, or in the notation form, a multiplied by calculate f given a, I and n. Oh, and also I have a sinking fund factor, which is the opposite of the future worth factor, which is convert f to annuity. I have a future value, I want to convert it to a uniform cash flow. And the equation is just reverse the future worth equation. A equals f multiplied by I divided by 1 plus I to the power n minus 1, or the factor notation f multiplied by calculate a given f, I and n. The other 2 factors are the present worth factor and capital recovery factor. The present worth factor is to convert a uniform series to a present value, and the capital recovery factor is to convert a present value to a uniform cash flow. And the equations as you can see it. This is something to think about. How long does it take to save $1 million at different interest rates? And as just to show you the power of the interest rate, if you save your money for 2,000 each year at interest rate 4%, you will need 78 years to have $1 million. But if the interest rate changes to 10%, you only need 41 years, which is approximately half the 78 years at 4%. Let's see some examples on the uniform cash flow. You are saving $3,000 in your saving account at the end of each year for 10 years. If the account earns 7% interest rate annually, how much can be withdrawn at the end of the 10th year? So this problem is given a, I and n, and I need to calculate the future value. So I need the future worth factor. F equals a for 1 plus I to the power n minus 1 over I. Plug in the numbers. you will get $41,449. Or using the interest tables, calculate if given A at 7% and 10 years using the 7% interest table at n equals 0, we can get this factor, which is equal to 13.8164 multiplied by 3,000. You will get approximately the same answer. The slight difference is due to approximation or the rounding in the factor. Now we have the same or the previous example, but now instead of depositing the money at the end of each year, we are going to deposit the money at the beginning of each year. I'm still going to have 10 deposits, the same, okay? But now the timing is different. Instead of putting the money in the bank at the end of the year, I'm going to put the money in the bank at the beginning of the year. So, as you can see for the last transaction here, I'm not getting any interest because I'm depositing it at the end of the year, so I'm putting it at the end of year 10 and withdrawing it at the end of the year 10. But here, the last transaction, since I'm putting it at the beginning of the year, okay, so it will have one interest period, one complete interest period, and I'm going to get interest for that for one interest period. So I'm expecting that the amount of money is going to be more because the last transaction I'm taking an extra interest for that. How to solve this problem? We can solve this problem in the short way and the long way. In the short way, we are going to use the answer from the example 314 and solve the problem. Note that if this cash flow isn't in the standard form of a uniform cash flow, note that at n equals 0, there should be no transaction. But if I extend my cash flow for 1 year, minus 1 for example, and there's no transaction at n equals minus 1, so from minus 1 to 9, n equal 9, I have a uniform cash flow. And I can apply the equations developed for a uniform cash flow. And for this cash flow, if I calculate the future value at n equal 9, I will have the same answer as the previous part, 41,449.2. Because I have 10 interest periods, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Now, this amount of money, I can treat it as a single payment cash flow and find its future value at n equal 10. So, the future value at 9, at n equal 9 multiplied by FPIN 7% and 1 year, I will get $44,350. We can solve this question the long way. As follows. For this transaction at n equals 0, I need to find its future value at n equal 10. And for this part of the transaction, I can find its future value at n equal 9 and then compound it till n equal 10. So the future value in equations is going to be 3000. Calculate F. I'm going to treat it as single payment cash flow. راح أعمله على إنه single payment cash flow. Calculate F given B على interest rate 7% and 1 year. Okay? Plus another 3000, 3000. But this time calculate F given A at 7% and 8 interest periods. I have 8 interest periods. 1, 2, 3, 4, 5, 6, 7, 8 interest periods. Okay? Multiplied by, now treat it as single payment cash flow, calculate F given B at interest rate 7% and 1 year. You will get the same answer. راح نحصل على نفس الجواب. Now let's examine different saving plans you celebrated your 24th birthday and you have 3 investment plans at annual interest rate of 8%. واحد بده يوفر مبلغ معين لحتى يجي يتقاعد يلاقي الفلوس هاي بعد ما يتقاعد. And he have 3 different plans and he's going to retire at the age of 65. So he will have 41 years to save money. Okay, 41 years. The first plan is that he's going to invest $2,000 for the first 10 years. Okay, he's going to save $2,000 per year for 10 years, and after that he's not going to deposit anything in the bank and let the amount accumulate in the bank till n equal 41. The second investment plan is that he's not going to invest anything at the first 10 years, but he's going to deposit $2,000 for 31 years. Plan C, starting from this year, at the end of each year, he's going to deposit $2,000 for 41 years. Which plan is better? So we can calculate either the present or future value, but for this question we are going to calculate the future value to see how much money he's going to have after 41 years. For the first plan, I can calculate the future value at n equal 10. Okay? And then compound it using single payment formulas until n equal 41. So 2000 calculate f given a at 10, calculate f given a at 8% and 10 years, then multiply it by calculate f given b at 8% for 31 years. Okay, to convert it from n equal 10 to n equal 41, you will get $314,000 and $870 $314 $870 في نهاية السنة 41. For plan B, I have annuity, but the annuity repeats for 31 years. I can apply the uniform cash flow formulas at this part of the cash flow. So it's going to be 2000 calculate f given a at 8% and 31 years. The answer is $246,000 $691. Plan C, its annuity for 41 years. The answer is going to be $561,000 $562 $561,562. So which plan is better? Obviously plan C is the best choice. I'm going to have more money at the end of year 41. But let's look at plan A and plan B. Although in plan B I invested more money, in plan B I invested $2,000 for 31 years. Oh, it's going to be $62,000. And in plan A I only invested $2,000 multiplied by 10 years, which is $20,000. Although in plan B I invested more, 62,000, but I got less. While in plan B I invested only $20,000 but I got more money. حصلت على فلوس أكثر 314,000. الآن ليش؟ Why? السبب, the reason is that I started investing early in plan A. So in each year, the first $2,000 I'm going to have interest rate for 40 years. And then I'm going to have interest rate for the second 2,000 plus the amount from the first year and interest and so on. So by the end of year 10, I will have much money and I will let it accumulate for 31 years in the bank. While in plan B, since I started late by 10 years, I missed the opportunity, this opportunity. راحت علي الفرصة هاي. Example 318, Biogen is a company, has borrowed $250,000. استعارت $250,000 to purchase laboratory equipment for gene splicing. بدهم يشتروا معدل المختبر يستخدموه في الجين splicing. The interest rate of the bank is 8% and the loan is going to be paid over 6 years. We need to compute the amount of annual installment. قديش راح يدفعوا سنويا لحتى يسددوا القرض اللي هو $25,000. So this question is given given PIN, calculate A. Okay, 25,000 multiplied by the factor APIN, plug in the numbers, you will get $54,000. The same question or the same example for Biogen, but now we have what we call it grace period. Biogen is going to borrow the same amount of money, $250,000, but they are going to negotiate the bank to have a grace period for 2 years. ايش معناته؟ بدهم البنك يأجل سداد القرض أو بداية سداد القرض لمدة سنتين. And then they are going to repay the loan over 6 installments. يعني حيدفعوا 6 دفعات زي المثال السابق. The same as the previous example. Now, what's the value of the annual installment? How much they are going to pay to the bank? The idea behind this question is that bank is not going to give you a grace period for free. For the bank, the $250, if the bank invests them for 2 years, he will get money for them. But since he's going to give you grace period for 2 years, he's not going to give that without any consequences. So from bank point of view, that he will consider that your loan will start at n equal 1, okay, and he's going to compound this $250,000 for 1 interest period. So the actual loan is going to be $250,000 compounded for 1 year at 8%. Calculate F given P at 8% and 1 year, which is $270,000. يعني فعليا القرض اللي اخذته شركة بايوجين مش 250,000. The actual loan taken by Biogen is $270,000. 270,000 بسبب because of this grace period, بسبب فترة السماح هاي. Now our present value is $270,000. Calculate A given PIN and just plug in the numbers. The answer is $58,401. Now let's see the Lewis outing example from the beginning of this chapter. And if you remember that Lewis outing won the lottery. Now let's consider that Lewis outing is going to sell her lottery ticket for $2 million, and let's assume that the interest rate is 8%. Was this a fair trade or not? Remember that she already cashed in the first check. أخذت الدفعة الأولى من الفلوس. So what's remaining is $280,000 for 19 years. Okay? هل ال 2 مليون اللي أخذتهم اليوم compared لل 280,000 على 19 سنة a fair trade ولا لا؟ Is the 2 million taken today equivalent to $280,000 at 19 years and interest rate 8% or not? We need to calculate the present value to compare the present value of this cash flow with the 2 million. If they are equal, we will say they are equivalent. There's no difference between the 2 million and $280,000 for 19 years and 8% interest rate. And if it is less, then it is not a fair trade. If it is more, it's not a fair trade. If it is less, then Lewis outing actually made a profit. So B, calculate B given A at interest rate 8% and 19, plug in the numbers, we will get the answer $2,689,008. So obviously it wasn't a fair trade because the future value, present value of 280,000 for 19 years at interest rate 8% is $2,689,000, while she got only $2 million for her lottery ticket. Now we come to the third type of cash flows, which is the geometric gradient, the linear gradient cash flow. The linear gradient cash flow is that we have a, the amount is increasing or decreasing by a constant amount, كمية ثابتة أو مقدار ثابت, and we give it the symbol G. And this diagram represents the gradient part of the cash flow, and note that the gradient starts at n equal 2. There is no gradient before n equal 2, at n equal 1 and n equal 0. So if there is any transactions at n equal 0 and at n equal 1, we have to consider them separately, because the equations we are going to see applies for this cash flow. This is the standard form of the gradient part of the cash flow. So how to treat gradient or linear gradient cash flows? For linear gradient cash flows, we have two cases. Either it's going to be an increasing linear gradient or a decreasing linear gradient. Those are the two cases. Okay. Any one of them, we are going to separate the gradient cash flow to two parts. The first one is a uniform cash flow, and the second part is the gradient series. Okay? Either it's increasing or decreasing, we are going to separate it to two cash flows, uniform and a gradient. Okay? If it is increasing cash flow, we will put plus sign. We are adding the uniform to the gradient. If it is decreasing, we put the minus sign. We are subtracting the gradient from the uniform cash flow. Now, for the uniform part of the cash flow, the amount of A is always the same as A1, whether it's increasing or decreasing. دائما اليونيفورم بارت الانويتي لليونيفورم بارت is the same as A1 of the gradient cash flow. Now we come to the formulas of the linear gradient cash flow. In the linear gradient cash flow, I have, let's say, three factors. Two of them is presented in the textbook, and the third one I added to the slides to know about this formula. The first factor is the present worth. Present worth means given given G, I and N, calculate the present value of the gradient. And this formula applies only for the gradient part of the cash flow. For the uniform, we apply formulas of the uniform cash flow. So I can convert this cash flow to its present value using this equation, or in the notation form using the interest tables. This factor you can find it in the interest tables. هذا الفاكتور ممكن نلاقيه في interest tables. The other factor which is in the textbook or the interest tables doesn't exist in the interest tables. هذا الفاكتور مش موجود في interest tables ولا حتى في المعادلات اللي في الكتاب. Is the future worth factor. Given G, given GIN, calculate F, the future value. And remember also that this formula applies only for the gradient part. I'm converting this gradient part to its equivalent future value. F equals G multiplied by 1 plus I to the power n minus 1 over I squared minus n over I. The third factor is uniform series factor, or calculate A given GIN. I'm going to convert this gradient to a uniform series, to a uniform cash flow. And also this factor, you can find it in the interest tables, AGIN. Let's see this example. Textile mill purchased a lifted truck that has a useful life of 5 years. شركة نسيج اشتروا شاحنة عمرها 5 سنوات. The maintenance cost for the truck during the first year will be $1,000. تكلفة الصيانة لها حتكون $1000 and it's expected to increase at a rate of $250 per year over the remaining life. والصيانة هاي راح تكلفهم في السنة الأولى $1000 لكنها بعد هيك راح تزيد بمقدار $250 كل سنة إلى نهاية عمر هاي التراك هاي الشاحنة. The firm wants to set up a maintenance account that earns 12% annual interest rate to pay all the future maintenance expenses. لحتى يصرفوا على الصيانة تبعتها بدهم يروحوا يفتحوا حساب في البنك بسموه maintenance account، ومن الفائدة أو من الأرباح المتحصلة على هذا الحساب راح يدفعوا تكاليف الصيانة. تمام، لمدة ال5 سنوات. How much does the company or the firm have to deposit in the account now؟ قديش لازم يحطوا في الحساب تبعهم اليوم لحتى يكونوا قادرين انهم يدفعوا تكاليف الصيانة لمدة 5 سنوات. So in the cash flow diagram for our question is, as you can see it, the first year is going to be 1000, it's going to increase by $250 in the second year, 1250, it's going to increase by another 250, it's going to be 1500 in the fourth year, another 250 in the fifth year, another 250 is going to be $2000. Now we are going to separate our cash flow to a uniform cash flow and a gradient cash flow. The annuity of the uniform cash flow is the same as A1. It's going to be $1000. For the gradient cash flow, the G or the gradient is $250 and will start at n equal 2. And I need to calculate B for this cash flow. So I calculate B of the uniform cash flow. بحسب B لليونيفورم كاش فلو من اليونيفورم كاش فلو فورمولاز باستخدام اليونيفورم كاش فلو فورمولاز، والجريدينت بطبق عليه البريزنت فاليو فورمولا. And the present value of this cash flow is the summation because this is an increasing cash flow لأنه متزايد، فتكون عندي البريزنت worth اللي هي B1 plus B2. So B1 is going to calculate B given AIN. For the gradient cash flow, calculate B given GIN. 1000 multiplied by 3.6048 plus 250 multiplied by 6.397. هاي الفاكتورز نجيبهم من الانترست تيبلز على 12% و5 سنين. It's going to be $5,204. Other example, John and Barbara have just opened 2 saving accounts. John و Barbara زوجين، كل واحد فيهم فتح حساب في البنك للتوفير. تعرفوا men thinks or women thinks differently than men. النساء بفكروا بطريقة مختلفة عن الرجال. John and the interest rate is 10%. Okay, John wants to deposit $1,000 in his account at the end of the first year and increase it by $300 for the remaining 5 years. بده يحط في أول سنة $1000، بعد هيك راح يزيد كل سنة $300. يعني السنة الأولى the first year is going to put 1000 حيحط 1000. The second year is going to put 1300. Third year 1600. Fourth 1900, 2200. And at the sixth year he's going to deposit $2,500. Barbara on the other hand, she doesn't want to have this type of saving. She wants to put a constant amount of money for 6 years. Okay, the same amount of money for 6 years. So she's thinking about a uniform installments or uniform cash flow. This is, I say, call it A. Now the question is, how much Barbara or should Barbara deposit in the bank so that both of them will have the same amount at the end of the 6th year؟ قديش لازم باربرا تحط في البنك لحتى يكون عندها في حسابها نفس المبلغ زيها زي جون؟ Or simply the question is, convert this gradient cash flow to a uniform cash flow. So this type of cash flow is increasing cash flow. Okay, increasing متزايد لأنه القيمة قاعدة بتزيد. صح إنه بالنيجاتيف, it's true that it's in negative, but it is increasing. In 1000 is becoming $2,500. So we are going to split it to two cash flows, uniform and a gradient. The annuity of the uniform is the same as A1, $1,000. The gradient part is $300. So we need to convert this cash flow to a uniform. This part, the uniform part, will not change. It's already uniform cash flow. So we need to convert this cash flow to uniform cash flow. A equals A1, $1,000. Calculate A given G at 10% and 6 years. So 1,000 plus 300 multiplied by this factor from the interest tables. So the answer is $1,667. So Barbara should deposit in her account $1,667.08 every year, so she will have the same amount as Joan at the end of the 6th year. The last example in the linear gradient cash flow, we are going now to calculate the future value. You make a series of annual deposits into a bank account that pays 10% interest. The initial deposit at the end of the first year is $1,200. Then it declines by $200 in each year for the next 4 years. How much would you have immediately at the end of the 5th year? انت قاعدة تحط فلوسك في البنك. أول سنة حتدفعي $1200, لكن السنة اللي وراها حتحطي مبلغ أقل بمقدار $200. So it's going to be 1000. The year after that it's going to be 200 less, so it's going to be $800, $600 and $400. So this is a gradient cash flow, linear gradient cash flow. It is a decreasing cash flow because the amount is decreasing. 1000 is decreasing by 200. So I'm going to split it to two parts, a uniform part, and the annuity is the same as A1, $1,200, a gradient part with G equal to 200, and I will put a minus sign because it is a decreasing cash flow. So the future value of this cash flow is F1 of the uniform minus F2 of the gradient part. Using the uniform cash flow formulas, F1 is A1 multiplied, calculate F given A at 10% and 5 years, minus, now for the gradient part, let's assume that I do not have the formula, the future worth formula. I'm going to use the interest tables. I need to find the present value for this cash flow and then compound it using single payment formulas. So calculate G, G multiplied by calculate B given G at 10% and 5 years. This is the present value of the gradient part. If I multiply it by FPIN, I will get its future value. Plug in the numbers, the answer is $5,115, $5,115. The last type of cash flows is the geometric gradient. Geometric gradient, the cash flow is increasing or decreasing by a constant percentage بنسبة ثابتة أو rate ثابت، معدل ثابت، وبنعطيه الرمز small g. And it is the same as the geometric gradient. The gradient part starts at n equal 2, okay? So anything before n equal 2 is not considered, or excuse me, anything at n equals 0 is not considered in the formula that we are going to develop. And in the geometric gradient series, there is no interest tables. And we have only one factor. We call it the present worth factor. فقط عندي مش موجود في الانترست tables وعندي معادلة واحدة له، فاكتور واحد له. that I can find its present value. بقدر أوجد ال present value. لكن زي ما بتعرفوا if I know the present value I can convert it to a future value, I can convert it to annuity. ما في إشي بمنعها. And for the present value we have two cases. The first case is if I doesn't equal G, and remember that we have two percentages. We have the interest rate is a percentage, and we have G which is also a percentage. And the I و G وكلاهما percent. The first formula if I doesn't equal G. If I doesn't equal G, I use this formula. If I equals G, the formula becomes much more simpler in A1 over 1 plus I. First example, Ansel Company, okay? Ansel Company is a medical device manufacturer using compressed air in solenoids and pressure switches to control various mechanical movement in its machines. شركة أنسل بتصنع معدات طبية. بيستخدموا compressed air, they use compressed air لحتى يتحكموا في آلات التصنيع اللي موجودة في صالة الإنتاج. To control, they use compressed air to control the machines in the production area. Okay? Now, over the years, the manufacturing area or manufacturing floor went through several changes. Okay? For example, they are installing a new equipment, so they will do piping, compressed air, they will connect it to the compressed air network. إذا ركبوا معدة جديدة راح يمدوا خطوط جديدة من الكمبرست اير لحتى يوصلوها في الماشين هاي. One machine gets out of the service, so they instead of cutting the compressed air pipes they only plug it. بحطوا عليها سدادة. Okay. وبالتالي therefore the compressed air delivery system is inefficient due to leaks. الشبكة واسعة كبيرة مش مركبة بشكل سليم في عليها تهريبات. الآن compressed air delivery system أو الحمل على الكمبرسور بزيادة، لأن الكمبرسور الآن بدها تزود الماشينز هاي بالكمبرست اير وبدها كمان ايش تعوض الفاقد بسبب التسريبات هاي. So the compressor is expected to run 70% of the time. الكمبرسور متوقع انها تشتغل 70% من الوقت. For example, in one day 24 hours اذا المصنع بيشتغل على مدة 24 ساعة معناته الكمبرسور راح تشتغل 70% من ال 24 ساعة، هي تقريبا 17 ساعة. If there's 24 hours a day, if they are working 24 hours a day, the compressor will operate for 70% of the 24 hours or approximately 17 hours per day. وزي ما بنعرف if the compressor operates for a longer time is going to consume more electricity. More electricity معناته راح يدفعوا فلوس أكثر. They are going to pay more money for the electricity bill. راح يدفع فاتورة كهرباء أكثر. The compressor consumes 260 kilowatt hour of electricity and the price of the electricity is $0.05 per hour, per kilowatt hour. Okay? And the plant runs 250 days per year, 24 hours per day. Now, if Ansel continues to operate the current air delivery system إذا استمروا في الوضع القائم حاليا التهريب والتسريبات راح تضلها تزيد. It will increase by 7% or the compressor will have to run 7% زيادة every year. معناته بدها تشتغل 7% زيادة، معناته أنا الكهرباء راح تكلفني 7% زيادة. The electricity is going to cost me another 7% every year, more every year for the next 5 years. Now, Ansel has an option to replace the piping network, okay, but this will cost them money. It will cost them $28,570. راح يكلفهم $28,570 لحتى يستبدلوا كل شبكة الكمبرست اير الموجودة في المصنع. لكن if they do this replacement the compressor will run 23% less. راح تشتغل 23% أقل. يعني الآن قاعد خلينا نحكي تشتغل 70% من الوقت أو خلينا نحكي 17 ساعة في اليوم. It's operating for 17 hours a day. It's going to operate 23 1% less, or 0.23 multiplied by 17 hours, okay, uh, or 1 minus 0.23 multiplied by 17 hours, or 70% multiplied by 1 minus 0.23, which is يعني راح تشتغل is going to operate 53.9% during the day. Or it's going to operate approximately 13 hours a day. Okay, but this will not change over the 5 years. If ANSEL interest rate is 12%, is the machine worth fixing now or not? First of all, I need to convert the information in the question to a cash flow. بحاجة إني أحول المعلومات اللي عندي في السؤال ل cash flow. أنا عندي مبلغ واحد. I have only one money value in this question, which is $28,570. لكن I have the information في هذا السؤال بقدر إيش أحولها to a money value اللي هي قديش أنا بدفع كهرباء سنويا، سواء خليت الوضع كما هو تمام أو إني عملت الريبليسمنت أو غيرت شبكة الكمبرسد اير. So I need to convert the information in this question to money. How much I'm paying for electricity. قديش أنا بدفع الكهرباء per year. Okay, for the two cases, if I keep the situation as it is or if I do the replacement. Let's consider the first case, or keeping the situation as it is. We are going to calculate the power cost for the first year. The power cost for the first year is the equation as you see it. So the 70% is the operating percentage of all the time. If I multiply it by 250 days per year, this will give me the operation days per year. كم يوم تشتغل عندي بالسنة. If I multiply it by 24 hours per day, then this is how much the compressor is operating, or operating hours per day. And I know that the compressor consumes 260 kilowatts per hour, which is the power consumption of the compressor per hour. Okay, then this is the amount of the electricity consumed for 1 year. If I multiply it by $0.05 per kilowatt hour, this is going to be the cost of the electricity for in the first year, which is going to be $54,600. Okay, now the second step is I need to calculate the power consumption during the remaining years. This is a geometric gradient, and the power consumption is going to increase by 7%. This means that also the cost is going to increase by 7%. So just 54,600 multiplied by 1.17, I will get 58. Okay, at n equal 1 is going to be 54,600 multiplied by 1.07, اللي هي 1 plus g. I will get 58,422. At n equal 2 is going to be 58. This is at n equal 2. At n equal 3, 58,422 multiplied by 1.07, I will get the cost of electricity at n equal 3, n equal 4. The same is going to be 62,512 multiplied by 1.07. You will get the power consumption at the end at n equal 4, and so on. Now, this is a geometric gradient. I only have one factor for the geometric gradient, which is the present value. I calculate the present value for this cash flow using the first formula, since I doesn't equal g. Remember that interest rate is 12%. So the answer is going to be $222,937. This is the present worth of the electricity cost if ANSEL doesn't replace the compressed air system. Now, if they replace the compressed air system, the compressor will operate 23% less, or the cost of the electricity at the first year is going to be 1 minus 0.23 multiplied by 54,600. So this is going to be annuity cash flow, uniform cash flow. To calculate its present value, we use the factor calculate B given A at 12% and 5 years. The answer is $151,552. 151,552. Now, does the system worth fixing or not؟ بستاهل اني اعمل استثمار تبعي ولا لا؟ Maybe the first answer comes to your mind, since I'm going to pay 151,000 بما اني راح ادفع 151,000 كهرباء، $151,000 for electricity, which is less than the 222,000 اقل من 222,000, then it's better to replace the compressed air system. Actually, the answer to the solution that we have to consider the investment that we have done. Here I have done an investment of $28,750. So we are going to compare the marginal revenue, which is the savings, how much I have saved as electricity cost, which is $222,000 minus $151,000. The cost without replacing the system and the cost after replacing the system. The net savings اللي أنا وفرته على حالي is $71,000, 71,000, which is clearly more than $28,570. So the answer is yes, the system worth fixing. بستاهل إني أعمل استثمار لأني راح أوفر، أو التوفير الصافي the net savings is $71,000, $71,000، بينما أنا دفعت 28,000. I paid $28,000. The last example, retirement plan to save $1 million. Jimmy, he wants to save $1 million when he retires after 20 years. بده يوفر $1,000,000 لحتى يلاقيهم لما يجي يتقاعد بعد 20 سنة. He is a self-employed individual. And Jimmy expects that, and he is going to invest his money in a bank that gives him 8% interest rate for 20 years. Now, Jimmy expects that his annual income will increase by 6%. Jimmy بيتوقع انه دخله السنوي راح يزيد بمقدار 6%. So he is going to put or to increase his savings by 6% every year. The question is, what should be the size of his first deposit? قديش أول مبلغ لازم يحطه في البنك ويزيده 6%, and he increases 6% every year for 20 years. So at the end of the 20th year, he will have $1 million in his bank account. So this is a geometric gradient, and I want to calculate its future value. But since I do not have a future value for the geometric gradient, I will find its present value and convert this present value to a future value. Since I doesn't equal G, I use the first formula and I calculate the present value. And note that it's going to be a function of A1, which is the unknown. But I know that the future value is equal $1 million. So future value $1 million is equal to the present value 15.5957 multiplied by A1 multiplied by the factor calculate FP at 8% and 20 years. Plug in the numbers, you will get those numbers. This answer, solve it for A1, you will get A1 equals to $13,757. So Jimmy must deposit 13,757 اليوم. لازم يحط في حسابه في البنك 13,757 اليوم and increase it by 6% each year, and he will have $1 million at the end of the 20th year. راح يكون عنده $1,000,000 في نهاية السنة ال 20. And by this example, we come to the end of this chapter, and these tables summarizes the formulas for the different types of cash flows: single cash flow, equal payment cash flow, and the gradient cash flows, linear gradient, and the geometric gradient. Wassalamu alaikum wa rahmatullahi wa barakatuh.